Hello, everybody. Welcome back to Calculus 3. Now we're going to do the homework assignments for Chapter 14, Section 4. Let's begin. For the function w equals 5x squared plus 10y squared, we're parametricized by x equals cosine t and y equals sine t, express derivative of w with respect to t as a function of t, both using the chain rule and expressing w in terms of t and differentiating directly with respect to t. Then evaluate w dw dt at 2 pi over 3. Okay. This is chapter 14, section 4, number 1. W equals 5x squared plus 10y squared. X equals cosine t, y equals sine of t, and eventually t is 2 pi over 3. So at first, we're asked to find the derivative using the chain rule and expressing, or just putting this in place of x and going from there directly. So let's first look at how we got from here. So the first one we have dw dx dt. Then we have dw dy dt. So the derivative of x is negative sine t. The derivative of y is cosine t. Now, this function with respect to x is 10x. That disappears. Times dx dt, which is negative sine t. Now dy dt, now dw dy with respect to this. So its derivative of y is to bring 2 down. Now dy dt, cosine t. All right, so now what is x? X is cosine t, so it's 10 cosine t times negative sine t. Y is sine t. It gives us negative 10 cosine t sine t plus 20 sine t cosine t. So it's 20 minus 10 gives us 10 cosine t sine t. At t equals 2 pi over 3, we get 10 cosine 2 pi over 3 times sine 2 pi over 3. Cosine 2 pi over 3 is negative 1/2. Sine of 2 pi over 3 is square root of 3 over 2. So the answer is going to be negative. The 10 and the 2 cancel. So it's 5 radical 3 over 2. That's the first one. That's the first method. Now the second method, x is cosine, so it's cosine squared t plus 10 sine squared t. Let's do it directly. So 5 is a constant derivative of this, bring the 2 down, so it's 10 cosine t times the derivative of cosine, which is negative sine t. Bring the 2 down, makes it 20 sine t, so just spread that down, times the derivative of sine is cosine. Negative cosine t sine t plus 20 cosine t sine t, which makes it 10 cosine t sine t. At t equals 2 pi over 3, we get the same thing because that's exactly what we had earlier. So the derivative of dw dt was 10 cosine t sine t. And when we finished plugging everything in, it was 5 radical 3 over 2. All right, number 2. Express dw/dt as a function of t, both using chain rule and expressing the terms directly with respect to t. And then evaluate dw/dt at the given value t. Number 2. W equals x over z plus y over z, where x is equal to cosine squared t, y is equal to sine squared t, and z is equal to 1 over 6t. Evaluate it when t equals 7. So let's first take the derivative, the partial of w with respect to x is 1 over z. The partial with respect to y is 1 over z. And the partial, it'll be bigger, partial with respect to z. Z goes up on the top, negative, so it becomes negative x z squared, negative y over z squared. Because remember, if we have this, z comes up to the top, the derivative is negative 1, subtract 1, which gives us negative x over z squared. That's how that works for z, or t, which is equal to negative x minus y z squared. All right. So what do I have now? I have dw dt is equal to dw dx dx dt dw dy dy dt dw dz dz dt. So dw dx is 1 over z. The derivative of x over, so dx is 2 cosine t negative sine t. The derivative of y is 2 sine t cosine t. And z is equal to, that goes up there, so it's negative 1 over 6 t squared. So dx dt is minus 2 cosine t sine t. dw dy is 1 over z times dy dt is 2 cosine t sine t. dw dz is negative x minus y over z squared. dz dt is negative 1 over 6 t squared. Okay. Now we have to substitute x, y, and z with respect to the functions of t. We have 1 over 6t. Remember, z is equal to 1 over 6t. One over 6t plus negative cosine squared t minus sine squared t over 1 over 6t squared times negative 1 over 6t squared. Well, these two are just opposites of each other. They're both sine 2 sine cosine over 6. So they just cancel. We can factor out a negative 1. So we have cosine squared t plus sine squared t on top. And on the bottom, we have 1 over 36t squared times negative 1 6t squared. So that equals 1. So we have negative 1 over that. So it's negative 36t squared. Negative 1 over 6t squared. The negatives cancel. Sixes cancel. Okay, let me see if I wrote that correctly. Negative x over z squared, 1 over 36t squared. And these two cancel. That becomes negative 1. Ah, that's what's right. Yeah. It's 6t. Yeah, so that cancels with that. So it equals 6t. So dw dt is 6t. Okay, for the first one, which of the equations represents the initial step? So we had 1 over z, 1 over z, not negative, so it's b. Negative it. Okay, the second step. What equations represent w in terms of x, or in terms of t? What's the derivative of w with respect to t is just 6. When t equals 7, it's still 6. Okay, that's that page. Number 3. Okay, this one's looking at the dependency diagrams. Draw a dependency diagram and write a chain rule formula for this. Z equals f of mn, m is kt. So z equals f, that's wrong. So the first one is with z with respect to m, z with respect to n. That's with respect to t, so that's wrong. So that one has to be A. Because the first step is z with respect to m, z with respect to n. Then dm dt, dn dt. So the formula is this times this, dm partial m partial z partial m. No. So this, because this is m, that's n, that's wrong. There's no plus here. There's a minus here. It has to be plus, so it's D. do another one. Now with three variables. So dw is g's xyz's. Okay, so it has to go w with x, w with y, w with z. This only has two, so it's b, has to have three dimensions. And that's not right. What's happening here is we take this product, and this product, and add them together. That's minus, that's not right. There's nothing. So it has to be D. Write the correct dependency for D. For W with respect to V. Okay, yeah, so we see here that X, Y, and Z are all DU and U's and V's. So it's going to look identical. It's going to look identical to this one, except it'll have DV. Because we first have to do it with the U, then we have to do it with the V. So it's C. So dx, dv, dy, dv, b. And the last one is, it can't be this one because it's minus. There's no sign there. So it has to be that one. It's dw, x, whatever's here has to go there. And that's what with the v. wy, y has to go there with the v. Because what happens, the x's cancel, we have wv. The y's cancel, wv. The z cancels, wv. Right. Assuming that 10x cubed minus 2y squared minus 8xy equals 0, defined y as a differentiable function of x, using the theorem dy dx equals that. Ten x cubed 2y squared minus 8xy equals 0. Dy dx as negative f of x, f of y. And then find dy dx at the point 1, 1. So according to this, we have to find the partial with respect to x, and then the partial with respect to y. So f of x is equal to 30x squared minus 8y. There's an x, there's an x. F with respect to y is negative 4y minus 8x. So dy dx is equal to the negative of f of x and f of y. At 1 and 1, yes. So when x is 1, it's 30 minus 8 is, it's a minus f of x. f of y so it's 38 because it's a minus f of x minus 38 over minus 12. No, this is out in front, so it's positive, so it makes it 22. 22 over negative 12. It's a negative of the whole function. So they both have a 2 in common. (11 over 6). Yeah. All right. Now number 6. There. If the equation f of x, y, z equals 0 determines z as a differentiable function of x and y, then at the points where f of z is not equal to 0, the following equations are true. Okay, that's what we just did up top. Use these equations to find the values of d partial z, partial x, partial z, partial y. So, okay. Number 6. So the equation is 2x cubed, no, 2z cubed minus 3xy plus 4yz plus y cubed minus 118 equals 0 at 4, 4, 3. So let's look at f of x. F of x is negative 3y. F of y is negative 3x plus 4z plus 3y squared. And f of z is 6z squared plus 4y. At 4, 4, 3, we get f of x equals negative 3 times 4 is negative 12. F of y is negative 3 times 4 plus 4 times 3 plus 3 times 4 squared. Negative 12 plus 12. So those cancel. 3 times 16 is 48. and f of z. 6, 3 squared, 4 times 4. 6 times 9, 54 plus 16. 70. So dz dx is negative f of x over f of z equals negative f of x is negative 12 over f of z is 70. Six over 35. And then partial of z, partial of y is negative fy over fz. Fy was 48, so it's negative 48 over 70. They both have a 2, so it's 24 over 35. So those are the answers. 6 over 35 and negative 24 over 35. And lastly, number 7. Probably have room to do it here. The temperature T is a two-dimensional function in which point xy satisfies t at x. The partial t at x, 1, 3 equals 4. Partial ty, 1, 3 equals negative 9. If x equals x, 3t minus 3, y is 3 plus ln t, these are both in centimeters, mercury. Find the rate at which the temperature changes when t equals 1. So t is a function of t, x, and y. So partial of t with partial of t with respect to x, partial of t with respect to y, so we know that tx equals 4 and ty equals negative 9. So this one equals 4. This one equals negative 9. All we have to do is find the derivatives of x with respect to t and y with respect to t. So dx with respect to t is 3 e3t minus 3. This constant is 1 over t. 3e3t minus 3, 1 over t. Twelve e3t minus 3 minus 9 over t. Now, when t equals 1, 3 times 1 minus 3. 3 minus 3 is 0. So that becomes 1. So it's 12 minus 9 is 3. When T equals 1, the temperature changes at a rate of 3 centimeters per second. Yeah, so once you finish the derivative. All right, that's that one. Good luck, everyone.